Student, your fast chemistry chapter, that is some basic concept of chemistry. We are going to discuss about different types of matters, their physical chemical properties, their classifications, their measurements. Okay. So student, what is matter? Matter is a substance which has mass and occupies space. They are called matter. Air, water, table, chair, benches, etc. These all are matters. That means it is a substance which has mass and they occupies a space. Now student, we classify all the matters according to physical classification and chemical classification. We get according to physical classification solids, liquids and gases. And according to chemical classifications, matters may be mixtures or pure substance. Then mixtures further divided as homogeneous mixtures and heterogeneous mixtures, and pure substance classified as compounds and elements. Elements further divided as metals, non-metals and metalloids. Okay. Now pure substance. A pure substance is one which is made up of only one kind of particles. They are called pure substance. Sulfur, hydrogen, chlorine, iodine, these all are the pure substances. Similarly, substances such as water, carbon dioxide, sodium chloride, sugar, copper, sulfate, these are also pure substance. A pure substance is recognized by its properties. Okay. For example, gold by its yellow color, and it is also malleable. Bromine gas by its brown color, and iodine has by its violet color. Okay. So pure substance are those which is made up of only one kind of particles. It may be atoms or molecules. Okay student. Now pure substance classified as compounds and elements. Pure substances are classified as elements and compounds. So an element is the simplest form of matter that cannot be broken down into simpler substances by chemical reactions. So an element is the simplest form of matter that cannot be broken down into simpler substances by chemical reactions. So if the substance cannot be broken down into yet simpler substances by any means known to chemists, it must be classified as an element. Thus, an element is the simplest form of matter which cannot be split into simpler substances by any physical or chemical method. Okay. So, an element is the basic form of matter and that cannot be broken down into simpler substances. And according to modern atomic theory, an element is composed of atoms of the same kind. Okay. And elements can be classified into metals, non-metals and metalloids. Metals are those substances which contain some special properties, such as metals are generally solid, metals have metallic lustres, metals have silvery grey or golden yellow color, metals are malleable, metals are ductile, metals are good conductors of heat and electricity, metals are generally hard. There is some exception also. Sodium, potassium is a very soft metal. Metals generally have high tensile strength. Metals generally have high melting and boiling points, and metals are sonorous. So these are the important features of metals. Okay. Students, now non-metals are those which have some special features. Maximum features are just reverse of metals, such as non-metals display a variety of colors. For example, bromine is red, brown, phosphorus is red or white, sulfur is yellow, graphite is black, and chlorine is yellowish green. Non-metals are not lustrous. Non-metals are soft, non-metals have low tensile strength, non-metals are not sonorous, non-metals have low densities, non-metals have low melting and boiling points, non-metals are poor conductor of heat and electricity, non-metals are neither malleable nor ductile. Okay, student. So maximum characteristics of metals and non-metals just reverse to each other. Okay. Now metalloids. Some elements show some properties of metals and some properties of non-metals. That is, they have intermediate properties between those of metals and non-metals. These elements are called metalloids. Okay. So students, some elements show some properties of metals and some properties of non-metals. That is, they have intermediate properties between metals and non-metals, such as boron, silicon, germanium, gallium. These are metalloids. They have some properties of metal and some properties of non-metals. Okay. Now student, we are going to say about compounds. A compound is a substance made up of two or more elements chemically combined in a definite proportions by weight. So a compound is a substance made up of two or more elements chemically combined in a definite proportion by weight. Okay, so a compound is a pure substance composed of two or more elements chemically combined in a definite or fixed proportion by mass. As a result of chemical combination, the original properties of the elements gets replaced by an entirely new set of properties that are characteristics of the compound. Clear? Compound have some special features or characteristics, as a compound is formed by the chemical reaction between two or more elements in a definite proportion by weight. Okay, and a compound are homogeneous, that is, they contain the same kind of molecules and thus their properties are same throughout. The components of compound cannot be easily separated by the mechanical or physical means, and the physical and chemical properties of a compound are entirely different from those of its constituent elements. For example, hydrogen is a combustible gas while oxygen is a supporter of combustion, but their compound water is neither combustible nor supporter of combustion. Okay, chemical compounds generally possess sharp melting and boiling points, and formation of a compound is associated with the absorption or evolution of heat, light or electricity. For example, the formation of carbon dioxide occurs by the absorption of heat. That is, when carbon burns in oxygen, we get carbon dioxide. Okay. Compounds are two types: inorganic compounds and organic compounds. Compounds obtained from non-living sources such as rock, minerals, they are called inorganic compounds. That is, when we get a compound from living sources, they are called inorganic compound. Non-living sources, they are called inorganic compounds. Chalk, marble, baking powder, these are the inorganic compounds. But when compounds obtained from living sources such as plants, animals, they are called organic compounds. For example, protein, wax, oil, petroleum, carbohydrates, these all are obtained from the living sources. It may be plants or animals. So when we get compounds from living sources, that is plants or animals, they are called organic compounds. Okay. Now we are going to say about mixtures. Mixtures is a substance in which two or more elements and or compounds are simply mixed together in any proportion. So a mixture is a substance consists of two or more elements or compounds in any proportion and not chemically combined together. For example, air is a mixture of oxygen, nitrogen, rare gases, carbon dioxide, water vapor. And these gases are not chemically combined together in the air. So mixture shows all the properties of its constituent elements or compounds can be separated into its constituents by simple physical methods. Okay, and compounds, depending upon the physical states of the constituents, a mixture, it may be homogeneous or heterogeneous. Depending upon the physical state of the constituents of a mixture, it may be homogeneous or heterogeneous mixture. Homogeneous mixtures of has a uniform composition throughout its mass. Okay, and it has no visible boundaries of separation between the various constituents of homogeneous mixtures. Exist usually in one phase. Okay, a mixture of sugar in water is a homogeneous mixture. A mixture of air is a homogeneous mixture. Okay, and a heterogeneous mixture is that in which the composition is not uniform throughout. Because of the uneven distribution, the constituents of the heterogeneous mixtures are visible with naked eye, or at least under microscope. Okay, a mixture of sand, salt, iron fillings is a heterogeneous mixture in which each constituent can be easily picked up by hand. Okay, so mixtures may be homogeneous or heterogeneous. Okay, the constituents of a mixture are not present in any definite proportion. Okay, and they may be present in any proportions, and constituents do not lose their characteristic properties in a mixture. So mixture shows the properties of all its constituents. For example, shikanji has the taste of lemon, salt and sugar. Okay, the components of a mixture can be separated by physical methods. The melting and boiling points of the mixtures are never sharp because we can change the constituents compositions. So its melting and boiling points also changes. No heat, light or electrical energy may be evolved or absorbed during the formation of a mixtures. Okay, students. So, students, we discuss all about the matters. Matter may be of three states. Okay, we can classify matter according to their physical state. They may be solid, they may be liquid, or they may be gas. Okay, in solid state, matters have fixed shape and volume. They are rigid and incompressible. They do not flow. They show only the slight expansion, and they have high density, and their melting and boiling points have fixed. Okay, and in solids, their intermolecular force of attraction is very strong. And in liquid state, liquids have a definite volume. Liquids have no definite shapes. They have low densities. They have slight compressibility. They show only the slight expansion, and they generally flow easily. Liquids have their melting and boiling points below the room temperature, and in liquids the intermolecular forces are strong but not enough to keep them together in a fixed position. Okay, and in gaseous state, Gases have no fixed volume and shape. They have flow easily or freely because the cohesive force in gases is negligible. They have low density because intermolecular space in gaseous is very large. They have high compressibility when they heated at constant pressure. Because in gases the particles are far apart and there is enough space available for the compression in a small cylinder. Gases have their melting and boiling points both below the room temperature. So these are the physical characteristics of solid, liquid and gases. Okay. Now student, we discuss about the temperature conversion. Temperature on the Celsius scale and Kelvin scale are related by a relation. That is, we can measure the temperature in degrees centigrade. It may be Kelvin scale or Rankine scale, Fahrenheit scale. Okay. So temperature on the Celsius scale and the Kelvin scale are related by the relation. That is, the relation is temperature on the Kelvin scale equal to temperature on Celsius scale plus 273. So for Kelvin scale temperature we have to add 273 with the centigrade scale temperature. And there is no direct relation between the Kelvin scale and Fahrenheit scale. So we have to convert the temperature of Fahrenheit scale into centigrade scale at first. Then we have to add 273 with this temperature and we can get in Kelvin scale temperature. Relation between centigrade scale and Fahrenheit scale is C by 5, that means centigrade scale temperature by 5 equal to Fahrenheit scale temperature minus, that is F minus 32 by 9. I am saying once again the relation C by 5 equal to F minus 32 by 9. Here C and F are centigrade scale temperature and Fahrenheit scale temperature. Okay, by these formula we can convert the centigrade to Fahrenheit and Fahrenheit to centigrade. Okay student, now student, we discuss about the different laws of chemical combination. Laws of chemical combination. Okay, the law of conservation of mass. Matter can neither be created nor destroyed. The total mass of the reactants must be equal to the total mass of the products. So total mass of the reactant must be equal with the total mass of products. For example, 12 gram of carbon react with 32 gram of oxygen and we get 44 gram of carbon dioxide. That is why we balance each and every chemical reactions. Okay, so according to law of conservation of mass, matter can neither be created nor destroyed. Okay. Now law of constant composition. A compound prepared by any method contains the same elements in the fixed ratio by mass. Okay. According to law of constant composition, a compound prepared by any method contains the same elements in the fixed ratio by mass. That is, water prepared by any method contains hydrogen and oxygen in a fixed ratio. That is 1:8 by mass. Okay, this is called law of definite proportions or constant composition. Now, law of multiple proportions. When two elements combine, when two elements combine to form two or more chemical compounds, then the weights of one of the elements which combine with the fixed weight of another bear a simple ratio to one another. For example, when carbon reacts with oxygen to form carbon monoxide and carbon dioxide, when carbon monoxide 12 parts by weight of carbon combine with 16 parts of oxygen, and in carbon dioxide 12 parts by weight of carbon combine with 32 parts of weight of oxygen. Show the ratio between different weights of oxygen that combine with 12 parts of carbon is 16:32, that is 1:2. I'm saying once again, according to law of multiple proportions, if two elements can combine to form more than one compound, the masses of the one element that combine with the fixed mass of the other element. When water formed, we get hydrogen and oxygen in 2:1 ratio. That is, when 2 gram oxygen react with 16 gram 2 gram hydrogen, when react with 16 gram oxygen, we get 18 gram of water. But when 2 gram of hydrogen react with 32 gram of oxygen, we get hydrogen peroxide. That is 34 gram of hydrogen peroxide. And in water, ratio of hydrogen and oxygen is 2:1. But in hydrogen peroxide, its ratio is 1:1. Student? Now, Gay-Lussac's law of gaseous volume. According to Gay-Lussac's law, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. For example, 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water vapor. 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water vapor. Thus, the volume of hydrogen and oxygen which combine in a simple ratio, that is 2:1. Avogadro's law. According to Avogadro's law, equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. And it may be atoms or molecules, which is quite understandable in the present times. If we consider again the reaction of hydrogen and oxygen to produce water, we see that 2 volumes of hydrogen combine with 1 volume of oxygen to give the 2 volume of water without leaving any unreacted oxygen. So according to Avogadro, equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Now we discuss Dalton's atomic theory. According to Dalton atomic theory, matter consists of indivisible atoms. All atoms of the given element have the identical properties. Including identical masses, atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Okay, such as for making of water, we get ratio of hydrogen and oxygen in 2:1 ratio. Okay, so compounds are formed when atoms of different elements combine in a fixed ratio, and chemical reactions involve the recognizable recognition of atoms. These are neither created nor destroyed in a chemical reactions. So, conservation of mass obey the Dalton's theory. So, according to this, matter neither be created nor destroyed. Okay. Atomic mass. So, the atomic mass or the mass of an atom is actually very, very small because atoms are extremely small. Okay. So, atoms so atomic mass. Student, the atomic mass unit is defined as the quantity of mass equal to 1/12 of the mass of an atom of carbon C12 isotope. Student, an atom is the smallest particle that takes part in chemical combinations, and the mass of an atom of an element is called its atomic mass. Okay, so the atomic mass unit is defined as the quantity of mass equal to 1/12 of the mass of an atom of carbon C12. Okay, now relative atomic mass. Relative atomic mass of an element is expressed as the number of times of an element of that atom is heavier than 1/12 of an atom of carbon 12. So atomic mass of element equal to, we can write mass of one atom of element divided by 1/12 mass of the one atom of carbon C12. So relative atomic mass of an element is expressed as the number of times of an element of that atom is heavier than 1/12 of an atom of carbon 12. Clear? Gram atomic mass. The atomic mass of an element when expressed in gram is called gram atomic mass of that element. Okay. Now molecular mass. The molecular mass of the substance is the sum of the atomic masses of all atoms in a molecule of a substance. The molecular mass of a substance is the sum of the atomic masses of all atoms in a molecule of a substance. For example, molecular mass of water equal to, that is H2O, we can write 2 into 1, that is 2, here 2 atoms of hydrogen, so 2 into 1, atomic mass of hydrogen is 1, plus 1 into 16, here oxygen atom is 1 and atomic mass of oxygen is 16, so we can write it 2 into 1 plus 1 into 16, that is 18 unit. Okay, and relative molecular mass equal to, we can write mass of one molecule of substance divided by 1/12 mass of one C12 atom. Okay, and gram molecular mass, the molecular mass of a substance expressed in gram is called the gram molecular mass of the substance. Okay. Now, student, what is mole? Okay. Uh, the number of atoms of an element present in 1 gram of it, or the number of molecules of a substance present in 1 gram mole of it, is called Avogadro's number, and it is expressed 6.022 into 10 to the power 23. Okay. So, student, now we say about mole. Mole is defined as the amount of a substance which contains the same number of particles, that is, it may be atoms, ions, or molecules, or electrons, as the number of carbon atom present in 12 gram of C12 isotope of carbon. I am saying once again, student, mole, the amount of substance which contains the same number of particles, that is atoms, ions, molecules, or electrons, as the number of carbon atoms present in 12 gram of C12 isotope of carbon. Clear? Now student, gram atomic mass. Gram atomic mass mass of an element is defined as the mass of Avogadro number of atoms. So mass of 6.022 into 10 to the power 23 atoms of hydrogen equal to 1 gram. So mass of 6.022 into 10 to the power 23 atoms of oxygen equal to 16 gram. Okay. So student, gram molecular mass gram molecular mass of any substance is defined as the mass of Avogadro number of molecules. For example, mass of 6.022 into 10 to the power 23 molecules of H2 equal to 2 gram. Mass of 6.022 into 10 to the power 23 molecules of O2 equal to 32 gram. Okay. Now student, we discuss about percentage composition. Okay. So percentage composition, the percentage composition of a compound represents the mass of each component in 100 gram of the compound. For example, the percentage composition of ammonia, that is NH3, is 82.35% nitrogen and 17.64% hydrogen. Okay. The percentage composition of methane CH4 is 75% carbon and 22.5% hydrogen. So the percentage composition of elements in a compound can be calculated from the molecular formula of the compound. Okay. For calculation of the percentage of each element in a compound, we have to remember that correct molecular formula should be known and the atomic mass of each element in the compound should be known, and the mass of each element in a compound is calculated by multiplying the number of atoms of each element present in the compound by the atomic mass of the respective elements. Okay student.